Hello friends, today we will solve more problems on equivalent circuits. The problem statement you can find on your screen. They are asking you to find an equivalent resistance between A and B, and as you can see the resistive network is given to you, which right now appearing to be complex. Believe me, even though in the gate problems the problem appears to be complex, most of the problems are most easy to solve. Let us see how to deal with this. If you see this circuit carefully, you can see that there are multiple bridges formed by resistor elements. For example, as you can see this part, if you see this part carefully, what you see, a bridge is formed having elements the way I'm drawing. Like every element is having same value, which is R. And as you can see, there is one more resistor which I'm pointing out right now, which is connected here. We know that looking at this bridge is appearing to be a balanced bridge. What is meant by balanced bridge? You have to see these two elements, R and R. Take a ratio of them, and that ratio is 1. Again, you take ratio of this R and this R. If it is also same, then it is said to be a balanced bridge. In balanced bridge, every point of the bridge, meaning that every node of this bridge, it's said to be equipotential. And we know the fact that through equipotential point or through equipotential circuit, current never flows. And that is the reason why I can neglect this R. So what happens is, this is bridge number 1, in which this resistor is said to be redundant one. As you can see, there is one more bridge here, which is also appearing to be a balanced one. So even this resistor gets redundant. Whereas you can see there is a third bridge here. As you can see, this R is also redundant. So now we need to draw an equivalent circuit having same elements, only rejecting those resistors which are redundant now. Let us draw that circuit in the next slide. So as you can see, we knew that the middle resistances, that is this resistance and this resistance, are redundant. So I'm just removing those resistors, and the equivalent circuit now will become like this. Yes. Now this is an equivalent circuit between 2 points which are A and B. This is point A and this is point B. As you can see clearly, these two resistances are connected in series. So R plus R will become 2R, whereas these two resistances are also connected in series, becomes 2R. So this is 2R, this is also 2R. Whereas let us see what happens with the remaining resistors. Observe these two resistance. Suppose this point, I consider this as A. Rather, let me consider some other point. Let us consider this point as X. Let us consider this point as Y. Now as you can see, this resistor R and this resistor R are connected in parallel with each other. That is the reason why I can again further reduce this R parallel with R, which ultimately becomes R by 2. We know the property, when resistors are connected in parallel having equal value, effective is always half of it, and that's the reason why R parallel with R becomes R by 2. Whereas if you see, this is also R parallel with R, so this will also become R by 2. We can continue further for next elements also. Like, if you see this carefully, R parallel with R will become R by 2. Again, R parallel with R, again this will become R by 2. The effective circuit can be drawn like this. It is like this: 2R in parallel with R by 2 is in parallel with R by 2. and further there is 2R, and this is an equivalent circuit between A and B. So now what we can do is we can further reduce it very easily. As you can see, R by 2 and R by 2 are parallel with each other. So this R by 2 and R by 2 are parallel with each other will further become R by 4. Whereas 2R and this 2R are also connected in parallel. Further, because of the parallel combination, it will become simply R. So what we can do is we can draw a circuit like this. This is R parallel with R by 4. Further, you have to only calculate equivalent impedance between A and B by having a parallel combination of R with R by 4. So now R parallel with R by 4 becomes R equivalent between A and B. So I can say RAB equal to 1 into 4 upon 1 plus 4 times R, which is 4 by 5 times R. So the equivalent value between points A and B is 4 by 5 times R. So equivalent resistance between A and B for this problem, that is RAB, is simply equal to 4 by 5 times R. Unit is ohms. I'm sure you understood this problem. With this problem, now we'll go to the next problem. So the next problem is appeared on the screen. In this problem, you have to find the value of I. As you can see, the direction of the current and the respective branch is also specified. That is, you have to find current through 18 ohms resistance. See, conventionally speaking, people will try to apply KVL. But as you can see, there are multiple loops. So if there are multiple loops, if I follow the approach of getting KVL in every loop, it is going to be too tedious. That is the reason why let us have some trick to solve this problem. You have to only observe the things that I am pointing towards. Check it out. 9 ohms and 5 ohms are connected in series. So 9 plus 5 will become 14. So if it is 14, then imagine that 14 ohms is connected in parallel with this 14 ohms resistance. Will effectively become 7. Now the equivalent resistance, which is 7 ohms, which comes in series with this 11 ohms, which will ultimately become 18 ohms. Now this 18 ohms, as you can see, comes in parallel with this 18 ohms, will effectively become 9 ohms. So this whole equivalent will become simply 9 ohms. After that, this 9 ohms comes in series with this 13 ohms, which is ultimately 22. And again, if I take 22 parallel with 22 will become 11. Meaning that if I actually calculate R equivalent of this circuit with respect to these 2 points, which is let's say A and B, I'll get value as 11 ohms. So I can draw the circuit like this, plus minus 44 volt, having an equivalent resistance of 11 ohms. Now, if I want to calculate a battery current is the current which is leaving battery, like this, can be calculated easily by having Ohm's law. So by Ohm's law, I will be equal to V by R, which becomes 44 divided by 11, that is 4 ampere. So what we know in this problem is a battery current, that is total current supplied by the circuit, which will be equal to 4 ampere. Now we will see how to deal with this problem and how to get the value of the current which is asked. So as we have seen, the equivalent resistance of the whole circuit was 11 ohms, and therefore I got the resultant current or a battery current which was equal to 4 ampere. So this is 4 ampere current. Now try to understand the case again. We know the fact that 9 parallel with 5 became 14 ohms. This 14 ohms came in parallel with the another 14 ohms, became 7 ohms. 7 ohm comes in series with 11 ohms, becomes 18 ohms, meaning that there will be a parallel circuit across this, like this, which will be 18 ohms. Now whatever current that flows through 18 ohms, the same current bound to flow through this 18 ohms also. Further, if I try to reduce the circuit, what do I get? 18 parallel with 18, it will be 9. With this 13 ohms becomes 22 ohms. Therefore, we'll have a circuit like this. 44 volt will have circuit like this. This is 22 ohms. This is 22 ohms. The first 22 ohms have come from this, and the other 22 ohms is obtained after reducing the circuit which is other than this 22 ohms. So the supplied current, we knew that it was 4 ampere. We know the fact that if there is a node formation, we know the fact that, and if the current is getting divided, current may get divided equally if there are equal resistances in both the branches. For example, as this circuit is telling you it is 22 ohms parallel with 22 ohms, it means the 4 ampere will get divided equally. So what we have, 2 ampere in this branch and 2 ampere in this branch, meaning that which is through the first 22 ohms is 2 ampere and the remaining 2 ampere goes via this. Further, think about this point. We know the fact that the current which comes at this point is 2 ampere, and again there is a node formation, current is getting divided into two parts. If you see carefully, the equivalent part of this circuit is again 18 ohms, meaning that this 2 ampere current will also get divided equally. 1 ampere will flow in this 18 ohms and the remaining 1 ampere will go through rest of the circuit. But then the current that they are asking you is nothing but this I, and by applying simply current division rule, we got this I to be 1 ampere, and that is our answer. So I is equal to 1 ampere is our answer. I'm sure you understood this problem. Now with this, we can start with our next problem. In this problem, they are asking you the value of Rxy, that is equivalent value between X and Y, where you can see this type of circuit is basically called as a ladder circuit, and this ladder circuit is a never-ending circuit. So it is like never-ending. This is moving up to infinity. Such circuit is having 2 points initially, which is X and Y. Within this, you have to find an equivalent circuit or equivalent resistance. We'll see how to deal with this. We know the fact that this is going up to infinity. So even if, let's say, 2 resistors are moved from this, like let's say this part is removed from the circuit, still if I again take X and Y point over here, I'll still get the same resistances value, meaning that out of infinity resistance, I'm just trying to move only 2 resistors, which is this 2 ohms and 2 ohms. It is not going to matter to the whole circuit. Since it is going up to infinity, you will be getting the same value of resistance, which is Rxy, at these 2 points also. Let me assume the equivalent resistance seen between X and Y is R equivalent, meaning that this whole circuit, let's say the equivalent resistance is R equivalent. But what we have to find? We have to find an equivalent resistance between X and Y. So what I'll be doing is, I'll be drawing the complete circuit. The only part is this whole circuit I will draw as a single resistance, which is R equivalent. So I'll redraw this circuit in the next slide. So this is the equivalent circuit of this. The remaining part, it's simply treated as R equivalent. And we have to see the value of Rxy. We can solve this further. We can see R equivalent and 2 ohms are connected in parallel. So the effective is 2 times R equivalent divided by 2 plus R equivalent, which is nothing but a parallel combination of this. Further, this resistance, which is 2 R equivalent upon 2 plus R equivalent, comes in series with 2. Now Rxy becomes 2 plus 2 times R equivalent divided by 2 plus R equivalent. Now we need to only solve this. In fact, this is R equivalent, then this is also R equivalent only. So what I can do is, I can replace Rxy with R equivalent. So I can treat this as R equivalent, which is cross multiplying this, we get 4 plus 2 R equivalent plus 2 times R equivalent divided by 2 plus R equivalent. Furthermore, shifting this term to the left hand side, what do we get? 2 times R equivalent plus R equivalent square, which is equal to 4 plus 4 R equivalent. So solving this equation, what do we get? It is R equivalent square minus 2 R equivalent minus 4 equal to 0. So as we can see, to find R equivalent, we need to solve this quadratic equation. So R equivalent value can have two values. It can be solved by minus b plus minus under root of b square minus 4ac by twice of a formula. So now it becomes 2 plus minus under root of b square, which comes out to be 4, minus 4 times ac, which comes out to be plus 16, divided by 2. So further if I solve, it will be 2 plus minus under root of 20 divided by 2. If I take 2 common, it will be 1 plus minus under root of, if I have to take 2 common, then from the root I'll be taking 4 common. So what remains inside is 5 divided by 2. So this 2 and 2 gets cancelled. So R equivalent have two possible values, 1 plus root 5 and 1 minus root 5. But the scenario is 1 plus root 5 will give you positive value, whereas 1 minus root 5 will give you negative value. We know the fact that R equivalent cannot be negative value. So R equivalent has to be only positive value. So selecting only positive part of it. Therefore, I can claim that R equivalent should be equal to 1 plus root 5. So this is the equivalent value of this resistance, which is 1 plus root 5. With this, let us start with our next problem. Let us start with the next problem that appeared on your screen. In this problem, we have to find the C equivalent between X and Y. So the problem is, you have to find CXY. In fact, looking at the circuit, you will realize that there are no two easy capacitors to identify, like they are connected in series or parallel. In this scenario, as we have seen from the earlier videos and the earlier problems, that such problems can be solved easily by point method. So let us have some points, like if this is X, this point has to be X. If this is Y, this has to be Y. This cannot be X, neither it is Y. Let us assume this is A and this is B. So this is X, this is Y, and there are two intermediate points, which is A and B. Let us draw a equivalent circuit. 1 microfarad connected between X and A. 1 microfarad. 5 microfarad connected between A and B. 6 microfarad is connected between B and Y. Three microfarad connected between A and Y. After that, one more capacitor is left, which is 2 microfarad connected between X and B. And we have to find equivalent capacitance between 2 points, which are X and Y. This is point X, this is point Y. Now, observe this. This is also forming bridge. In most of the gate problems, whenever it is forming a bridge, most of the times it is balanced bridge. Check it out. You have to see the adjacent arms, which is 1 microfarad and 2 microfarad is having ratio as 1/2. 3 microfarad and 6 microfarad will also have a ratio of 1/2. If such ratios are same, the given bridge is said to be balanced. And in case if the bridge is balanced, I can claim that point A and point B are equipotential. If they are equipotential, a current will never flow through it. And that's the reason why the component which is between A and B can be ignored, which is 5 microfarad in this case. So this 5 microfarad is said to be a redundant one. So let's draw a new circuit. We started with point X. After that, we have 1 microfarad and 2 microfarad. 1 microfarad and 2 microfarad here. After that, we have point A here. So at the end of 1 microfarad capacitor, we have point A. After point A, there is 3 microfarad capacitor. At the end of 2 microfarad, we have point B. So we have point B here. After that, we have 6 microfarad capacitor connected between B and Y. So we have 6 microfarad. After that, 3 microfarad and 6 microfarad have a common endpoint, and we have Y. Now it is very easy. 1 microfarad and 3 microfarad in the upper branch connected in series. 2 microfarad and 6 microfarad are again in the lower branch connected in series. Having their equivalent capacitances will be like this. For upper branch, where 1 microfarad and 3 microfarad are connected in series, equivalent can be taken as 1 into 3 upon 1 plus 3. 1 into 3 upon 1 plus 3. So, the value of the capacitance which is in upper branch is 3/4. 3/4 microfarad. Whereas in the lower branch, the equivalent capacitor can be 2 into 6 upon 2 plus 6. Which comes out to be 12 upon 8. By reducing, I can say that it is 3/2 microfarad. So through this, it is connected in parallel, which is 3/2. Then 3/4 microfarad and 3/2 microfarad are connected in parallel. Finally, I can say that CXY will be equal to 3/2 plus 3/4. By having LCM as 4, I need to just multiply with 2 in the numerator, which becomes 6 plus 3 divided by 4, which comes out to be 9/4 unit is microfarad. Finally, we have CXY value as 9/4 microfarad. I'm sure you have understood all the problems in this video. Thank you so much for watching the video. Stay tuned with Ekeeda. Subscribe to Ekeeda.